Hi. In this example, I'm going to show you how to simplify this radical expression, the square root of 5x times the square root of 10x cubed, by putting them together inside one radical. Typically, one radical is better than two, so if you can simplify it, you want to. The thing that's going to let us do this is the fact that these are both square roots. You notice we have the square root of 5x and the square root of 10x cubed. Since they are both square roots, meaning they are the same type of radical, that's what lets us put them together in one. It's the first thing we need to make sure that we have. So these are both square roots. We can tell here there's no number as part of the index. Since there is no number, we assume it's a 2, and that's what's going to let us do this. Now, you can follow the same procedure even if they were both cube roots or both fifth roots. Whatever the index is, it's fine. You just want to make sure that they match. So whatever you have here, you have the same thing over here. Since these do match, we can go ahead and simplify them. And instead of writing it as two separate ones, we can just write it as one big one where we multiply the radicands together. So we will multiply 5x times 10x cubed. And instead of having them separate, put them in one. This lets us now take the inside and simplify it, putting it in simple radical form. Meaning anything that's a perfect square, anything we can take the square root of, we will, so that we get the smallest amount of stuff possible underneath the radical. So it is possible, you can, if you want, go ahead and multiply the 5 and 10 together and rewrite this as 50x to the fourth. But I'm going to leave it as is, because one of the first things that we want to do is break this up into prime factors to see what we're really working with. 5, the number we have here, is already prime, so I can leave that alone. Now I want to deal with the 10. Well, 10, you know, is 2 times 5. Those are its prime factors. So instead of 10, I want to use that and write it like that. All I'm going to do next is rearrange these, put them in order from smallest to largest. So we actually have 2 times 5 times 5. Now we have 4 x's multiplied together, so that's x to the fourth. And that's what I really have inside this radical. So here, the 2 times 5, that's my 10. This 5 was the one we had here. So if you multiply this together, I still have 50x to the fourth, the same thing I had before. Running out of room, so let me move this up so I have some more space. This is what I'm working with actually inside this radical. This is what I want to use to simplify it. So to simplify it, since we do have a square root here, I want to take this and rewrite all of the factors in pairs if I can, meaning that I want to write everything with an exponent of 2 if I can. Well, I only have 1 2 here, so there's no way to use a 2 exponent with that. But you notice I do have 2 5's multiplied together, so those I can put using an exponent. So I have my 2 times 5 squared. X to the fourth, we can leave it x to the fourth, but it'll be easier to simplify it if we recognize that that's x squared times x squared. Since this is a square root, and the square root and the 2 exponent cancel each other out to a certain extent, that's the easiest way to look at this. From here, ultimately what we're really doing is taking anything that has a 2 as an exponent and taking it out of the radical, meaning that we'll end up taking this 5, pulling it out front, taking this x, pulling it out front, and taking this x and pulling it out front, meaning in the end we're going to end up having 5 times x times the square root of 2. But I'll take you step by step through that so you see how it actually works. We put 2 radicals together in one in order to multiply these, but we also can break it apart now, and breaking it apart helps me. So instead of writing it as one long radical, I'm going to take each factor and write it under its own. So I have the square root of 2 times the square root of 5 squared times the square root of x squared times the square root of x squared. All of these that are perfect squares will simplify. This one will simplify, this, and this, getting rid of those radicals. So, square root of 2, The only way I could rewrite that in a more simple form would be to round it and use a decimal, but I want to keep this as accurate as possible, which means no decimals. So I'll leave it the square root of 2. Next up, square root of 5 squared. Well, the radical and the exponent, the square root and the square, pretty much just cancel each other out and we end up with 5. Now for the x's. Technically, the square root of x squared is not x. It's not just that these two cancel each other out. It's actually the absolute value of x, which if you recall, we would denote like this with bars. What that means is that it ensures x is positive, because in the end, the square root of x squared is positive x, meaning if x was negative in the first place, you would make it positive through this whole process. But we're going to change the instructions for this problem a little bit and assume that my x's, my variables, are all positive, so I don't need to worry about the absolute value bars. So for this problem, and for many of the ones you face, you'll see that instruction as part of it. So we can take this and simplify the square root of x squared as just x, not the absolute value of x. So we end up here with this one simplifying to x, and same thing here, square root of x squared. Because of that restriction as part of our instructions, we'll simplify that to be just x. Now it's just a matter of rearranging and writing it in a slightly nicer form. We have the square root of 2 times 5 times x times x. So I will rewrite that as 5 x squared times the square root of 2. That's my answer in simple radical form. Now if you look and compare this answer with what I suggested up here, you'll notice that what I said would happen would happen. This 5 ends up getting pulled out and moved into the front. And the same thing goes for this x and this x. So in the end, we end up with 5x squared times the square root of 2, and that's because 2 was the only thing that didn't have a 2 as an exponent. It has to stay inside the radical. So it's sort of a shortcut you can use to skip some of the steps once you feel comfortable with it. Thank you very much.